going to start today with the first of the background knowledge topics, which is surds. A surd is a radical. International term for radical is a surd. Real numbers, and I'm not going to read this all to you, but highlighting a few things. Radicals are surds. Now notice here they talk about only having second power roots. Okay. These are second power roots, not third, fourth power roots. But surds are, it is continuous. So you can have third power roots, fourth power roots, fifth power roots, and they're still called surds. We're going to focus on what we do in this unit on the second power roots, because we haven't done a lot of study at this point on the other types of roots. So we want you to be able to work with the roots as second powers or as second roots, but we will later on add in the idea of third, fourth roots, fifth roots, and so on. We still work with it in the same way. All right, before we talk about this, let me show you something. Let's see if you remember this. I'll come back to that in a second. Do you know how to do that? What's that? 7 up. No problem, right? You should know how to do those with something else. Let's replace those with a surd. In other words, a square root. So that's 3 times the square root of 2 plus 4 times the square root of 2. You do it the same way. There's no difference. It's 7. Now that's 7 square roots of 2. 7 times the square root of 2. But I'm not multiplying the square root of 2. I'm adding. When we get down here, yes, it will change. But here I'm just adding. Right? So here, this is the same. I'm still going to take 4 square roots of 5 minus 2 square roots of 5 is 2 square roots of 5. I don't do anything different. You treat them as variables, unknowns, because do we know their exact value? No. They are what we call what type of number? Irrational. Those are irrational numbers. We can estimate their equivalence, but we can't get you an exact answer. 1.414 is the approximation of the square root of 2. We want exact answers. Do exact answers matter? Yes, exact answers matter when you're designing an airplane. Square roots of 2 times 3 square roots of 2. Well, just like you did over here, that is 6 square roots of 2 squared. But what happens to a square and a square root? They're the opposite of each other. They are inverses, so that's 6 times 2, which is 12. So this is equal to 12. If you have like bases, you square them, the radical goes away. What if you don't have like bases? What if you have something like this? I still get 6 times the square root of 2 times the square root of, let's say, 5. Because they're different radicals. X is different than y. Well, you can do this. That's 6 times the square root of 10. But it's the square root of 10, a simple answer. No. A radical A is never negative. It can't be. Why not? It's not real, right? We talked about imaginary numbers already a little bit last year. If A is negative, it means it's an imaginary number, so we're not going to look at those yet. We do get to them this year. We talk about complex numbers, so we'll explore that. A is meaningful for only when A is greater than 0. A times B, or the square root of AB. So if you have the square root of 20, that's the same as the square root of 4 times the square root of 5. That's basically what this is saying. Because isn't 4 times 5 20? So the square root of 20 is the square root of 4 times the square root of 5. You can break it down into smaller parts. Okay? And same thing here. If I have the square root of 50, isn't that the same as the square root of 200 divided by the square root of 4? Well, 200 divided by 4 is 50. So you can do those types of things as well. We're going to write these as a single surd. What do you think the answer is here? Square root of 6. Because there's a 1 in front of there and a 1 in front of there. It's 1 times 1 is 1. Square root of 2 times square root of 3 is square root of 6. Next one, what's the square root of 18 divided by the square root of 6? Square root of 3. You basically write it 18 over 6. The square root of 18 over 6 is the square root of 3. What's 4 square roots of 5 plus 2 square roots of 8 minus 3 square roots of 5?
Students, please solve this now. Stop the recording and record your answer. We've now paused and we will move on.
We can only combine like radicals. We just talked about this. Radicals need to be simplified. That's where this, let's talk about the square root of 18. The square root of 18. Do you remember what perfect squares are? What are the perfect squares? Starting with the smallest perfect square. What's the smallest perfect square? 1. Perfect squares. 1, 4, 9, 16, and so on and so on and so on. And you can always find another one. What are they? 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared. Notice what else do we know about perfect squares? They always have a square root. Do with the square root of 18 to simplify, and this is crucial. IB expects you to, and I expect you to, simplify any radical any time a radical is used. If it can be simplified, it must be simplified. Okay? So, are there any perfect squares that will divide into 18? Not that 18 will divide into, but any perfect squares that will divide into 18. 9. Isn't that 2 times 9? Alright, so we know that 2 times 9 is 18. Now what happens is you break it into parts. The square root of 9 times the square root of 2. What's the square root of 9? 3. So really we have 3 square roots of 2. This is simplified. This is the correct answer in the eyes of IB. This is not. All radicals must be simplified. That's why I still have the square root of 2. It stays in the radical because it doesn't have a perfect square, so it stays inside the radical. So another example might be the square root of 8.
Class, solve the square root of 8 or simplify the square root of 8 to its simplest form. Please record your answer in your notes. You can pause the video.
Rationalizing a denominator. This is the last thing. You cannot leave a radical in the bottom of a fraction. Cannot leave a radical in the bottom of a fraction. It's called rationalizing the denominator. We looked at this last year at the end of the year. 9 over the square root of 3. I can't leave the square root of 3 down there. How do you get rid of it? Do you remember, Chris? Multiply the top and bottom. Multiply by 1, right? If I multiply it by 1, I don't change the value of it. But what does 1 look like? 1 is going to look like the square root of 3 over the square root of 3. I'm multiplying by 1, correct? If I multiply by 1, it doesn't change the outcome or the value of the problem. So really what I have, when I multiply, I have 9 square roots of 3 over, what's the square root of 3 times the square root of 3? Square root of 9, or rid of the radical in the bottom. Should I simplify that? If I can, you should. Can I? Can I take 12x divided by 4? So can I take 9x divided by 3? Yes. Those can be simplified, correct? The square root of 3.
That concludes our first lesson of the flipped classroom in Math SL. Your assignment is here, which you will get tomorrow when you come to class, and this is what we will work on tomorrow in class. Please bring your notes, the 2 problems I've asked you in this video to solve, and come prepared, and we'll see you tomorrow.